Okay, so don't forget on Thursday, so 3 days from now, you're going to have your first exam right before we get out for Thanksgiving break. This material, the current lesson, tangent, cotangent, and so forth, will not be on the test, but graphing, sine, and cosine will, along with law of sines, law of cosines. You are allowed to use a note card. In fact, the whole reason I'm letting you use a note card is because of that ambiguous case. You remember that table off of the law of sines and cosines notes? I would definitely have that written on your note card because there are problems that tie to that. Anything else you want to put on there is completely up to you. I would know about the area of the triangles, like Huron's formula, or the 1/2, the product of the two sides times the sine of the angle included. Okay. But we've been talking about tangent since Friday. We just introduced this. In fact, this is the first graph we've seen that has what? Okay, asymptotes. Okay, because there are locations where tangent's going to be undefined, where we can't go ahead and get an answer. And then we talked through the characteristics, and I believe we ended up with one problem done. Okay, the one thing I want to go ahead and talk about very quickly before we get to that last problem, even tangent, okay, just like cotangent, as you're going to come to find out, they have critical values that we're going to look at across a period. But what is tangent's period? It's pi. Okay, so it only takes half as long for tangent and cotangent to start repeating as it does the other four graphs. That's going to be really, really important to us. But for tangent, the critical values of any one of the periods, undefined, because that's where an asymptote is, -1, 1, 0, undefined. And if you just follow along, those are the y values of one of those branches. Okay, well, let's go ahead and take a look. And I don't believe I mentioned this the other day, but I do want to go ahead and mention it because it's really easy to forget. What's the formula for the period of a function? It's 2 pi over b, right? But it's not the same formula when it comes to tangent and cotangent. For a period of tangent and cotangent, it's just pi divided by b. Why is that? Yeah, because the period for tangent and cotangent is pi, not 2 pi. Okay, so it's really easy to forget, but you just want to make sure you have that written down. Okay, let's go ahead and graph B. Let's talk through it. Okay, get another example, and then we'll go into cotangent. We'll see how far we can get. All right, so tangent of pi over 4x plus 2. All right, so A looks to be just a +1. We have B right here. Now, is 2, does that represent C or D? Okay, so Connor says D. What do you guys think? Okay, D. So Dylan agrees with him. How would I know that that 2 isn't a horizontal transformation, but he's a vertical? Okay, what's that, Aiden? There you go. There are no parentheses. If there were parentheses here, then I would absolutely say that 2 is C. But since there's no parentheses, I have to believe he's outside. So that's going to affect the midline. Okay. Now the pi over 4, he is definitely horizontal because he's multiplying against x. Okay. Now there is one change. When you're trying to graph tangent and cotangent, you're not going to start your compound inequality between 0 and 2 pi. What you're going to want to use is a pair of consecutive asymptotes. What does that mean, consecutive? Okay, Raphael? Repeating? Okay, so then he did that. So I think I know what you're meaning. Okay, now he gave me a thumbs up. So we're talking about one right after the other, right? Right next to each other. Okay, there we go. That's consecutive. Now, I personally prefer to go ahead and use negative pi over 2 and pi over 2. I mean, as long as the two asymptotes are one right after the other, doesn't matter. You'll always get the graph. Okay, but if you start going a little further off, your graph, you're going to get points that don't fall on the grid that you have, so you might want to just consider that. But I'm going to use negative and positive pi over 2. Okay, so negative pi over 2, less than or equal to pi over 2. So I know my upper and lower boundaries for my compound inequality, but what am I going to put in between them? What's inside this tangent function? Okay, Christian says pi over 4x. He's absolutely right. Anything that is affecting x is what's going to go in your compound inequality. So pi over 4x. Okay, let's go ahead and solve this. In fact, what would I do? Okay. So let me go ahead and put this in brackets to help distinguish from what we're doing. So I'm going to multiply by, we can go ahead and multiply by 4. I'm going to go ahead and multiply by 4 over pi to go ahead and take care of the whole thing. So the pi's are going to cancel, so negative 4 divided by 2. 2. Negative 2. Less than or equal to, reciprocals are going to give me 1. Less than or equal to 2. Okay, so I've simplified my compound inequality. Remember, it doesn't matter if theta's in there, you're still going to do the same thing. If you don't like theta, just replace it with x or vice versa. Okay, so I've got this set up. So now I'm not going to use him again until I get the critical values taken care of. All right, so what were the critical values for tangent? Let's see, if I go back over here, we started with what? Undefined. We start with one asymptote. And then we had a minimum, a negative 1. And it's a, I would probably describe it as a relative minimum, definitely not an absolute. But then what was after that? Let's see, what came after the negative 1? 0. And then we have 1. And then we finished up with the second asymptote. So that represents the y values of one period. Okay. So what do I see in this function that's going to be changing those 5? What did we not include inside? Okay, so Jacob says plus 2. Absolutely. Is there anything else outside? No. Okay. So the only vertical change is just the plus 2, right? So you remember like on the homework, we had the negative 3, bless you, and then the, I think it was a minus 2. Okay. Whatever those transformations are, you apply them one at a time to these 5. So what's an undefined plus 2? It just stays undefined, right? Okay. So I know that's going to stay the same down here. But now negative 1 plus 2. Positive 1. And then 0 plus 2. And then 1 plus 2. So remember, what are these that I just created? Are they the x's or the y's? Y. Those are the y values. Those are my criticals. Okay. So those are all my y values. Now, this compound inequality that I started with, those are going to help me with my x's. How do I pair these up? Okay, the lower boundary always goes with the first critical, so I'm going to put negative 2 here. The upper boundary always goes with the last one, so I'm going to put 2 right here. So that takes care of that. Okay, but how do I figure out, again, what I'm going to add? Satish? Okay, so he's saying between negative 2 and 2, he says that's a distance of 4, right? There you go. Whatever distance you have, we always, always, always divide by 4. Will we always do that? Always, yes. So 4 divided by 4 is 1. Now, you'll know you've got the right distance if you can start with that lower boundary. Just keep adding that value over and over again, and you should be getting your upper boundary exactly. So let's see, negative 2 plus 1. Negative 1 plus 1 plus 1 plus 1 does give me 2. Okay. And see, just like sine and cosine, we're giving ourselves 3 ordered pairs on one period. Now you notice I only said 3 ordered pairs. Why didn't I say 5? Yeah, how would I graph negative 2 undefined? Satish just said it. That's the what? That's the asymptote. So I know there's an asymptote at negative 2. I know there's another asymptote at positive 2. Remember, that is one period. Okay. And let's see here. I'm just going to go ahead and graph the other ones one at a time. Like I have negative 1, comma 1. So negative 1, comma 1. Then I have 0, comma 2. And then I have 1, 3. All right. So it looks like that right there should be tangent of pi over 4x plus 2. That's one period of that function. Okay. And again, how similar was that strategy-wise to what we did with sine and cosine? Pretty much the same, right? Now, here's the thing. I would like at least 2 periods. Now, Mr. Heinrich might require more. I don't know. I'd have to talk to him about that. But do I have to do this whole process over again? Or how can I get another period for this? Yeah, just copy it. Okay. How far apart are the asymptotes from each other? Okay, they're 4, right? So I'm just going to go 1, 2, 3, 4. I know there has to be another asymptote right there. Then I know that midway between them, you've got to have a point that's 2 up. So right here. See, I'm just going to copy the points. It's all about your patterns. So you don't have to go through this whole process again. Once you get 1, boom, there you go. And then I could do that as many times as I wanted. Okay. All right, questions. Anybody having a hard time? No? Okay. Well, let's take a look at cotangent. Okay, so the graph of cotangent is going to have a period of pi as well. But he's going to look a little different than tangent. They are cofunctions. So again, we'll explain what that means probably right before Christmas. Depends on how long it takes us to get through the inverses. But let's start with cotangent. If you were to evaluate a trig function on the unit circle like you were doing on your happy minutes, what's cotangent's ratio? It's x over y. Remember, we did the same thing on Friday with tangent. Okay, so x over y. And we know by now x is cosine. What's y? Sine. We did the same thing on Friday for tangent, but remember, he was sine over cosine. So in order to get the graph of cotangent, I'm going to focus on sine. Okay, what does sine look like? Where does he start? He always starts at 0. And if you're going to go ahead and draw a sine, remember to draw him very lightly because you're going to be erasing this. So we have a 0, maximum, 0, minimum, 0. And then that pattern continues in the other direction. Minimum, 0, max, 0. Okay, so there's sine. Okay. Now, is cotangent a sinusoidal function? Remember, what does that mean? Yeah, it's just a transformation of sine. We'll see cotangent is definitely related to sine. Okay, so he is a sinusoidal function. But why would I draw sine, though? Okay, Aiden, you said the zeros are what? There you go. Because it's a problem for cotangent wherever sine is 0. Because you can't divide by 0. That's where it's undefined. So any place this graph of sine touches the x-axis, cotangent's going to have a asymptote. And you'll notice how far are those asymptotes from each other? Pi. Okay, between each one of those asymptotes, you're going to see 1 period of cotangent. All right, so now I don't need sine anymore, so I'm going to go ahead and erase all these. In fact, you guys remember, I think it was last week or the week before, when I was saying it was so important that we be comfortable with sine and cosine because they were going to help us with the others. Okay, this is exactly what I was referring to. Okay. Well, midway between each pair of asymptotes is going to be a x-intercept. Hello. Okay. Are you on? It says you have a parent waiting. Good. Okay. There's going to be an x-intercept. So I know there'll be one here at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. Okay. Now, the period, whether it's 2 pi, pi, does not matter. We always, always, always divide by what? 4. We want 4 congruent distances horizontally within each period. That's what separates my critical values here, right? Well, what's halfway between 0 and pi over 2? So this is pi over 4. And what's halfway between pi over 2 and pi? 3 pi over 4, right? Because the distance for each of these is going to be just adding pi over 4 over and over, right? Okay. Well, I want to go ahead and tell you, when x is pi over 4 and you plug it into cotangent, you're going to get 1. When it's 3 pi over 4, cotangent will give you negative 1. So here's what cotangent looks like. Okay. Now remember those values, because I'm going to go ahead and once again relate it back to the unit circle. Okay. What's happening at 0? What does cotangent have here? It has an asymptote, right? Well, let's take a look at the unit circle. Cotangent of 0, remember cotangent wants x divided by y. So at 0, that's telling me to take 1 and divide by 0. Well, that's why we have an asymptote there, because you can't do that. Now look at your distances. Let's rotate around. Cotangent of pi over 4. Again, the x divided by the y. Well, what's square root of 2 over 2 divided by square root of 2 over 2? 1. So that's exactly why here, went to the wrong one. We have pi over 4, 1. Okay. Now the next increment would be pi over 2, right? So if I come back over here, let's now go to pi over 2. But what's that x divided by y? Yeah, so that's why we have pi over 2, 0. Okay, one more rotation, 3 pi over 4. Same thing, but now it's what? Negative square root of 2 over 2 divided by square root of 2 over 2 will give me negative 1. Now, what happens when I complete the cycle, when I get to pi? Negative 1 divided by 0, it becomes undefined. So see, that pattern is just going to continue as you rotate around. Okay. So I know that I'm going to have the same points just over and over and over again. Okay. There you go. That is cotangent. Now, let's go ahead and choose one period. Let's choose this guy right here. Let's say 0 and pi. Okay. What would his critical values be going left to right? We start with a what? Hello.
Just doing a camera walkthrough.
Okay.
Thank you. Looks like you're great.
Okay. Okay. So what are we starting with? So we start with an asymptote. We have undefined. Then what's the y value here? 1. Then we have a 0, negative 1, and then we get back to our asymptote. So whenever we want to go ahead and graph some kind of cotangent function, we're going to be using these guys. Okay. Remember, tangent's going to have his own critical values. They're very, very similar to each other. Okay. Well, let's see here. What would the range be? Let's start with the easy one. Yeah, it's all reals. He's infinitely tall, right? So it'd be negative to positive infinity. What's the y-intercept? There isn't one. Okay. The parent does not have one. Okay. Now let's go back to the domain. Will this continue forever to the right and left? Yeah, the pattern will repeat, but I can't say just all reals because of the asymptote. So just like we've done before, we got to figure out the location of those. So it looks like I have 0, pi, 2 pi, negative pi, negative 2 pi. So what can I say? X doesn't equal what? Pi what? Pi n. Oh yeah, this is the class that likes n, right? Okay. Every other class we did k, so that's fine. So pi n. We just want to make sure to list n's a what? N is an integer. There we go. Now, if I already have that domain, that does give me something else. Because what did we just identify the locations of? The asymptotes. So I'm going to write the exact same thing here. I'm just going to say x equals instead of not equals this time. So the asymptotes are always located at multiples of pi, so long as n is an integer. Okay. X-intercepts. So it looks like we have pi over 2, 3 pi over 2. The next one would probably be at 5 pi over 2. Oh, I got 1051. Okay. I'll tell you what, we'll go ahead and start there. Just kind of remind me how far we got. Okay. And then we'll transform, and I should be able to show you secant and cosecant tomorrow. All right. Thank you very much, guys. You have a great day. I will see you tomorrow.